All right, here we go. Do this with me. 4 to the 5th means 4 times 4 times 4 times 4 times 4. Yes, but only a few times on this one. 4 to the 3rd means 4 times 4 times 4. Now, it takes a while. Well, guess what the conclusion will be? There's a rule to go with this. But for now, write down 5 4s on the top, 3 4s on the bottom. Each time I have a 4 over 4, what does that equal? No?
20 over.
What's 4 divided by 4? This. So that's 1. That's 1. That's 1. Okay, it's not going to equal 1 though. Don't add them. You multiply them. There's 3 1s. If you multiply 3 1s together, you get 1. And if you multiply 1 times any number, you get that any number, right? So what numbers are left here that are not 1s?
3 4s.
2 4s. So this is equal to 4 to the 2nd. Notice here, what's the difference between the powers? What's the difference between the two powers? 2. So keep that in mind. Okay, this time we're going to write C times C times C times C, and then C times C times C times C times C times C times C. Okay, 1, 2, 3, 4, 5, 6, 7. Good. Okay, don't worry, we won't have to do this much longer. Every time I have a C over a C, what's that equal to?
1.
3.
Okay, there are 3, but where are they located? Below.
So it's negative.
Yes. 1 over C to the 3rd. You're right, whoever said that, Jared. You're right. They would have been negative, but then I would have moved the negative power to the bottom. So you're right. So this one we had a bigger number on top. This one we had smaller number on top, and so it ended up on the bottom. Basically what happens is, however many 4s there are on the top than the bottom is what you have as your power. And here it's however many C's you have on the bottom versus the top is how many C, the power for your C on the bottom. What about here, guys? Okay, we're not going to write it all out though, guys. We're not going to write it out this time. It's x to the 12 minus 5 power. Guys. Okay, we're not going to write it all out this time. We're going to be smart about it. It's x to the 12 minus 5 power, which is x to the 7th. Here's what the rule says. If you're dividing powers with the same bases, we subtract the exponents. Or another way to think about this is to ask yourself, where do I have more and how many more? I'll show you what I mean by that. But write this down. If you're dividing powers, what do we do with the exponents? Big, bold. So we've seen when we're multiplying powers, we add, and when we're dividing powers, we subtract. Here's another way to think about it. Which, the top or the bottom, which has more 4s here? Top. How many more 4s does it have? Yeah, the 50-50 chance. That's it. No. So let me ask the question again. How many more 4s are there on the top than on the bottom? 2 more, so that's our power. Which one has more C's, top or bottom here? How many more? Okay, see how that works? So it's a canceling sort of rule. So let me let you write down the rule. Go ahead and do that right now. Both rules. All right. So here's one where guys, we're not going to be able to count up x to the 3 halves power. Okay? You'd have to draw an x and then a half of an x. That would look fun. I guess you could. But, we're going to subtract 3 halves minus 1. Here's another way to think about 3 halves. Guys, here. Jose, go ahead and have a seat, please. Thank you. So it's another way to think about this is x and 1.5 minus x to the 1. So if you subtract, whoops, I didn't write that right. X to the 1.5 minus 1. What's 1.5 minus 1? Yeah, just 1/2. It's like your cookies. You have 1.5 cups of something, you take away a cup, you have a half a cup left. So this is just x to the 1/2 power. So even if you have fractional powers, we can do it if you remember that when you're dividing, you subtract the powers, okay? So if you're dividing, subtract the powers. What about when we have more than one letter in the problem? Let's write down the M. What do we do with the powers on M?
There's a whole list of words here.
If we're dividing the M's, what do we do with the powers on the M's? Hey, you know what to do? What do we do with the 2 and the 5? Okay, we were dividing the M's. What do you do with the powers? Or we don't divide the powers. Subtract them. So 2 minus 5. And then write down N. What do we do with the powers on the N? So it's 2 minus 5 is -3. 4 minus 1 is 1.
Braden, can I have the scissors back, please?
Yeah, sure.
Okay, but we're not done, guys. We've got to deal with this negative power.
You can't.
You do. Where do you move it? Move it down.
Look, I'm walking with the scissors out. What?
All right. Okay, these we've done some like these already.
He's the funny guy that took my present.
You've got to apply that third power. Oh wait. You've got to apply that third power to both the top and the bottom. Every number and every letter in the top and the bottom gets this third power applied to it. So we have x to the 9th and 5 to the 3rd, and you can leave it like that. So just apply the power outside the parentheses to everything, top and bottom in parentheses, numbers and letters. Okay?
Jared.
Right up there, it's x to the 9th over 5 to the 3rd. So here, I'm going to apply the 2 power to the 2. So it's 2 squared. I'm going to apply it to the a, so that'll be a to the 6th. And then I'm going to apply the 2 to the power on b, which is b to the 4th. Okay?
Erica Don? Yes, you need to be paying attention to this and writing the note.
What about this one? I have a -2 power. You have to look on your paper. That's a -2 power. So I apply the -2 power to the x. If I apply the -2 power to the y, I'm going to have y to the -4 power. Now, what do I do with these two to make them both positive? Switch it. The bottom goes to the top, and the top goes to the bottom. That's it. All right, last one on here. Apply the -3 to the 2. Apply it to the x. And apply it to the y. And then we got to do the old switcheroo with every one of these, okay? So draw your fraction bar. The 2 to the -3 goes to the bottom and becomes 2 to the +3. The x to the -18 goes to the bottom and becomes x to the +18. And y to the -12 goes to the top and becomes y to the 12.